So, in last class I was discussing about the calculation of the volume of a cube, measuring the side or edge of the cube. So, this student 1, student 2 and student 3, they used this meter scale, slide calipers and screw gauge, and they calculated the volume. So, this for student 1, this answer should be the 1150 volume cm cube, of course, if it is in centimeter cm cube, and then for student 2 the answer will be 1174 cm cube, and that for student 3 the answer is 1175.9. So, actually calculator was giving this type of number, right, and how to write the result, that is what we are discussing. So, as I told, there are two ways. To decide how to write the correct answer. So, one is following the rules of significant figures, and another is calculating the maximum probable error. In fact, we need both of them to write the correct answer. So, from significant figures we have learned that this answer should be like this, that we have discussed, and uncertainty will be in this measurement or in this result will be in the last significant figure. So, for this last significant figure, so basically it is a significant figure for this number is 3. So, last significant figure is 5, 0 is not significant figure, significant digit. So, uncertainty will be in this last significant figure. So, it is a result, this error in this measurement using the meter scale. So, this it can be 1150, 1160, 70, whatever, depending on the. So, from this result, from this significant figure, we cannot say, we can say this what is the order of the error in this result, but exactly we cannot say what is that, either it is plus minus 10 or plus minus 20 or plus minus 30, that we cannot say, but error will be in last digit. Okay, that is the uncertainty in the last significant figure. Okay. So, here this significant figure is 4. So, error will be here at the last significant figure, that is 4. So, error will be plus minus 1 or plus minus 2 or plus minus 3. So, 1 to 9, it can be 1 to 9 any number error, and similarly here this error is, so here significant figure is 5. So, last figure is 0.1. So, here the error will be in this decimal point. Okay. So, to know the exactly what will be the amount of error in this volume. So, whatever this we write plus minus some error. So, to find out that one, we have to calculate most probable error, and we have to know how to calculate that one. So, that is what I will discuss today. So, maximum probable error, how to calculate maximum probable error. So, Actually, actually we measure some parameter, but calculate something else depending on the relation of the measured parameter with the calculated parameter, right. So, error, although it is directly involved with the measured parameter, now to get the error in calculated parameter, so there is a procedure. So, basically error will propagate from the measured parameter to the calculated parameter. So, that is a propagation of error. So, most physical quantities usually cannot be measured in a single direct measurement. First, we measure one or more quantities that can be measured directly and from which the quantity of interest can be calculated. That is what I was telling. For each measurement there is an uncertainty. So, uncertainty or error is associated with each quantity. Now, what is the uncertainty in the calculated quantity, which is or which has well relation with the measured quantity. Okay. So, that relation can be in terms of summation, in terms of difference, in terms of multiplication or division or together some relation. Okay. So, in case of summation and difference, say q equal to, so equal to x plus y. Okay. So, x and y are the measured quantity and q is the calculated quantity. Okay. So, x and y are measured quantity. So, that we express generally this x best value plus minus uncertainty, y similarly y best value plus minus y uncertainty. Okay. So, q and q we can write q equal to q best value plus minus del q, delta q. Okay. So, this equal to basically x plus y, q equal to x plus y. So, x best plus minus delta x plus y best plus minus delta y. So, from here you can write this. Okay. So, now if you compare with this, so q best is basically x best plus y best, and error, what will be the here basically q equal to this. So, this plus this. So, what will be the largest value of q? This plus del x plus del y, right, and what will be the smallest value of q? So, this plus this minus of q del x plus del y. So, it can be del x minus y, it can be minus del x plus y. So, there are 4 possibilities. Okay. Out of these 4 possibilities, so largest value will be this and lowest value will be this. So, then we can tell that this most probable uncertainty, most probable, so other value will be between these two. Okay. So, most probable uncertainty del q will be plus minus del x plus del y. So, q best equal to x best plus y best, and uncertainty in q, that will be del q equal to plus minus this. So, similarly for difference also we can show that whether it is summation or difference, in both cases the uncertainty is basically, in calculated parameter uncertainty is basically sum of the uncertainty of the measured quantity, right. So, that is what in next I can show you that if you proceed same way, q equal to x minus y. Okay. So, if you proceed same way, here also you will see that largest value of q is this and smallest value of q will be this. Here this is the value, but uncertainty is the whatever individual uncertainty that will be added, for the uncertainty of the calculated quantity. Okay. So, for summation and difference in both cases, so uncertainty is basically maximum probable error is basically summation of the individual error, right. So, that is the, so you can take this in general way. So, if some relation q equal to x plus y plus z minus u plus v plus etcetera. So, so what will be the error in delta q? So, this delta q will be del x plus del y etcetera, del u plus del v etcetera. Okay. So, errors in computed value of q is the sum of all original error associated with with directly measured quantities. Okay. So, these basically we tell the absolute error. So, in case of summation and difference, so this error summation of individual errors gives the basically error in the calculate quantity, that is absolute error. Okay. And relative error basically we tell this del q by q or del x by x, del y by y. So, these we tell relative error. So, in case of summation and difference subtraction, so absolute error are added. Okay. But in case of product and division, you will see there this not absolute, this the relative errors are added. Okay. So, that I will show for next. So, here product and quotients, okay, division. So, if q equal to x y, again q x equal to x base plus minus del x, y equal to y base plus minus del y. So, fractional error or relative error, as I told this del x by x or x based, del y by y or y based. Okay. So, this briefly we write del x by x and del y by y. Okay. So, x equal to x based if you take common. So, 1 plus minus del x by x. Okay. Similarly, for y you can write. So, q equal to x y. So, if you put these two x based y based and 1 plus minus del x by x plus minus del y by y, del x and del y generally this is a small value. Okay. So, this is a second order error. So, we can neglect it. Okay. So, from here what you are seeing this again the same way, if you proceed, largest value of q will be this plus this 1 plus this and smallest value will be 1 minus this. Okay. So, again you can write that this q equal to q base plus minus delta q. So, if you compare q equal to q based plus minus delta q equal to q based 1 plus minus delta q by q based. Okay. So, it is the in mod. So, if you compare with this one, so then you can see that delta q by q equal to delta x plus delta y by y. So, in this case, so relative errors are added. So, for product we are seeing that relative error of individual measured parameter. So, that are added which gives the error, relative error of the calculated parameter. Similarly, if you choose for this division q equal to x by y, if you proceed same way, here also you will see del q by q equal to del x by x plus del y by y. Okay. So, either division or multiplication, in that case the relatives or fractional errors are added to get the relative error of the calculated parameter. Okay. So, if you generalize it, so this q equal to x into y into z etcetera divide by u into v into w etcetera, then the error will be del q by q, relative error equal to. So, these are measured quantity. So, del x by x plus del y by y plus del z by z plus del u by u plus del v by v etcetera. Okay. So, as I told, this fractionals error or relatives errors of the measured quantities are added which will give the relative error of the calculated quantity. Okay. So, for summation and for subtraction, for product, multiplication, for division, okay, or the mixture of them in a relation. Okay. So, there these rules will follow to calculate the error in the calculated parameter. Okay. So, there is an alternative way to find the error. This basically it is very simple. So, say q equal to x plus minus y. Okay. Just take log in both sides. So, log q equal to log x plus minus y, then differentiate. So, del q by q equal to del x plus minus y by x plus y. Okay. So, then del q equal to, so q we multiplied here. So, q is basically x plus minus y. Okay. So, this will go. So, this equal to del x plus minus del y. Okay. So, we are going to find out the maximum probable error. Okay. So, this here del x plus del y and del x minus del y. So, which one will be maximum probable error? So, del x plus del y. Okay. So, that is why we write maximum probable error equal to del q equal to del x plus del y. Okay. So, this for x plus minus y. So, this so whatever we have learned that for summation and subtraction these absolute errors are added for getting the error in the calculated parameter. Similarly, for q equal to x y, take log q equal to log x plus log y. So, del q by q equal to del x by x plus del y by y. Okay. Similarly, q equal to x by y. So, this log q equal to log x minus log y. So, del q by q equal to del x by x minus del y by y. Now, again this logic is maximum probable error. We have to find out maximum probable error. So, these are the relative individual error. So, we will not write this minus sign. So, we will add them. Okay. So, del q by q maximum will be del x by x plus del y by y. Okay. So, these are very simple way we use just quickly to find out the form of error of the calculated parameter from the measured parameter. Okay. So, now how to calculate error, so that we have learned. So, this we will apply for our example, that to find out the volume of a cube. Okay. So, let me go back there. So, this so basically answers now we are writing following the maximum probable error. So, what is the relation with volume and the our measured parameter? This is side of the or edge of the cube. So, volume V equal to A cube. Okay. So, take log ln V equal to 3 log n log A. So, del V by V equal to 3 del A by A, right. So, del V equal to 3 del A by A into V. So, V is A cube. So, basically 3 A square del A. So, error in V, so that will be 3 A square del A, right. So, now for student 1, del A is basically least count of the instrument used to measure the length. So, LC least count for student 1 it was 0.1 centimeter, right, and side was 10.5, right. So, so A we know and del A also we know. So, if you put the 3 into 10.5 into 10.5 into 0.1 cm cube. Okay. So, this is coming 33.075. So, del V is coming 33.075, right. So, this we are writing approximately 30. Why we are writing 30? Why not 33? Okay. Reason is that, so V we got from calculation concerning the significant figure, this V is 1150, right, 1150. Now, error we are getting here this 33 point something. So, now this we are writing 3, reason is that the error will be generally your whatever result, this rule is that this order of the last significant figure, whatever the order of the last significant figure, okay, and the error has to be also of same order. So, this is the volume, in this volume what is the order of the last significant figure. So, error also whatever we are writing, so that has to be of the same order. So, here this the 5, whatever the order of this position of this 5, it is okay. So, it has to be of same order. Okay. So, that is why it is 30. I cannot write 33. Okay. I cannot write 33. So, it is the significant figure 30 is the one, right, of this. Yeah. So, here this so this last significant figure. Okay. So, it is whatever order of this one and our this error, it has to be of same order. So, that is why this. So, now you see from significant figure we are able to write correctly the answer. Also we are able to tell correctly the error in which order, okay, in which digit the error is there, and after calculation we are seeing exactly that is true, right. So, but that time I was not able to tell this whether it will be plus minus 10 or plus minus 20, plus minus 30 or plus minus 40. Okay. But now to get that one you have to calculate the this error. Okay. So, it is basically plus minus 30. Similarly, for student 2 least count is 0.01 centimeter, that is delta A is 10.55. So, if you proceed, del V equal to 3 into A into this this one. Okay. So, your result will be this. Okay. So, okay. So, here actually I forgot to tell you, actually in you remember for significant figure what is the rule, this whatever the multiplication, this parameters are there. Okay. So, these factors are there. So, smaller factors, whatever the smaller factor will have the significant figure. So, result will have the same significant figure. Okay. So, among these, so 0.1 is the smaller factor and its significant figure is 1. So, this is the result, I cannot accept that one. So, I have to write, so result has to be also of significant figure 1. So, that is why it is 30. Yes. So, similarly here, so smaller factor, this one the smaller factor and significant figure of this one is 1. So, this is the calculating result. Okay. So, result it has to be of significant figure 1. So, it has to be 3, right. So, 3 is having significant figure 1, right. So, for student 2 result will be 1174 plus minus 3. Okay. So, earlier we came to know that error will be at this last significant figure. So, it can be 4, it can be 5, 6, 7 whatever, uncertain here. So, exact what amount of error that we are not able to say, but now we are able to say it is plus minus 3. Okay. Similarly, if you proceed for student 3, then you will see the error, this error for this case is 0.3. Okay. Following the same rule, you can say it is a 0.3. Okay. So, result will be 1175.9 plus minus 0.3. Okay. So, so actually from significant figure itself we can find out this error, it will be 30 or 3 or 0.3. Okay. So, now that whatever rule I told you, so from this result you can see, you can conclude that the error and the result, okay, it has to be of same order. Okay. It has to be of same order, it has to be so of the last significant figure. Okay. So, whatever the result, whatever the order of the last significant figure, error will be of the same order, error will be of the same order, error will be of the same order, last significant figure error will be of the same order. Okay. So, I think this is a good example, and from this single example I think I told everything, how to write the result, how to find out the error. Okay. And yeah, this is very important. Generally most of the time we do mistake for writing after calculation, to from the calculator whatever result we get, from there up to which decimal point we should keep, etc., etc. So, they are always confusing. So, so in experimental physics 1 I discussed this about significant figure and etc., but I saw that there was some confusion among the student, and they requested me to repeat this class. Okay. So, that is why I repeat this again this class, but in different way. Okay. Hopefully, it will be useful for you. So, I will stop here. Thank you.